All right, this is Algebra 2, Lesson 105. Ladies and gentlemen, I'm on page 433. The title of this lesson is Advanced Factoring. All right, so let's talk about factoring. We factored so far. What are the ways we factored? Like that. What are ways we factored that? We've asked ourselves two questions. Factors of
Factors of x that add up to -1.
factors of -6. Just that when we add them, it's -1, right? Okay, we're going to call it simple factoring, right? Simple factoring. And when we factor, why do we factor? What are we solving for? Okay, what is this factor? Go ahead and give it to me.
X plus
-3 plus 2.
Yeah. Why do we factor? To find what? Roots. What's another word? Roots. Solutions. Another word. Zeros. Another word. X-intercepts. X-intercepts. All right. So it's -2 and +3, right? So what if I just gave you the x-intercepts? Could you come up with the equation? What if I told you the x-intercepts are 4 and -1? What would the equation be? Where would you start?
X squared plus 3x minus 4.
Yeah, you'd add them. Your factors would be x minus 4, x plus 1.
Minus 1.
Plus, because it's minus the value. Got it? It's the opposite. Remember when we graphed it, always in with x is always the opposite? It's the same every time. All right, so yes, be x squared minus 3x minus 4. All right, so you could go from factors to the equation, right? It's important to go both ways. All right, what was our lead coefficient here? 1. We've also factored or solved by completing the square, right? That's probably your least favorite method, completing the square. We graph parabolas by completing the square. We also factor by completing the square. All right. What's going to be different with this lesson is we don't have a lead coefficient that's 1. We now have a new lead coefficient other than a 1. All right, so everybody look at me. I'm teaching this lesson different from the textbook. The textbook is no surprise, right? The textbook is trial and error. Mine is one and done. Got it?
I like that better. It's probably.
Yes. Okay. Some of you are going to work these like the textbook, and I will say, I'm sorry. My way's better. Okay. All right. So, let's start with example 1. Example 1 is 6x squared plus x minus 2. All right, we're going to ask this question. We're going to look for factors of a times c. What's my a value in this equation? 6. And my c value? So we're going to look for factors of 6 times -2, which is -12, such that when we add them, the result is the b value. What's my b value? 1. All right. So we're multiplying a times c, looking for that value. And we want factors of that value such that we add them and get b, but we're not done at that point. All right, so what are factors of negative 12 such that we add them and the result is positive 1? Caroline,
-3 plus 4.
say that again.
-3 positive 4.
-3 positive 4. Got it? Okay.
Is that the answer?
No, I'm not done. Okay, so everybody listen to me. I'm about to do what looks like division, but it's not division. It's sort of just like a trick. It's not a trick. It works every time. It's patterns. Okay? It's the way the pattern works. All right? So hang with me. Over my factors. You hanging with me, Paul? I'm going to write the lead coefficient with an X. Lead coefficient with an X. It's not division. It helps me get numerically to where I need to be, okay? It works 100% of the time.
So basically just take the,
Wait, before I write the factor, I'm going to simplify the numbers, okay? So this becomes a 1 and that becomes a 2. Got it? Okay, everybody look, I'm reading bottom to top. It's 2x minus 3. That's that factor. No, 2x minus 1, sorry. 1, Paula. I
Why
simplified.
is it like that?
Okay.
Yeah.
It works every time. You don't have to do trial and error. The textbook is trial and error. Okay? Got it? All right, then I look at 6 and 4. I simplify before I look at the term. 2 goes into both of them, right? So that's 3 and that's 2. So what's the factor? 3x plus 2.
oh, so that's,
Okay, wait just a minute. This also gives you the answer. But let's just verify. I can go ahead and show you what the answers to x are, all right? It's right here before your very eyes. All right, let's do it. 2x times 3x, okay. 2x times 2, 4x minus 3x, -1 times positive 2. Okay, it works every time. Okay, look, here's your solutions for x. It's the opposite. So it's 1/2. Do you see 1/2? Does everybody see 1/2?
yeah.
It's the opposite. And -2/3. So you also get the answers. Does everybody see that?
How'd you come up with this?
Okay, I didn't. Someone else did. It's much smarter than me. I'm just a math nerd and look at every way to possibly factor. I used to teach it a different way. I used to teach it like the textbook. I went to a different method and I landed here. Okay? So there's actually 2 other ways to do it. Okay?
Which one's the best?
This one. Today, anyway.
Teaching us the best one.
Okay? All right. So practice makes progress. So let's do number 2. All right. First, you have to have your equation in descending exponential order. All right. What's the first question I ask myself? Factors of what?
A times C.
A times C. What is that? What's A times C?
2 times negative 15
2 times -15,
is negative 30.
-30, such that we add 2 numbers and the result is
Negative 7.
the B value, -7. Okay, what are factors of -30 such that we add them, don't shout it out, such that we add them and the result is -7. I want everyone thinking, and Luke, when you get the answer, I want you to tell me factors of -30. When I add them, it's -7.
3 and negative 10.
3 and -10. That is correct. Okay. Then what do? I write these over the lead coefficient with an X. Lead coefficient with an X. I simplify the numbers when I can. All right, can I simplify this?
No.
So what is my factor?
2x plus 3.
That's correct. Bottom to top. It's not really division. What's the answer for x? X is, if I were solving, setting this equal to 0,
It's 3 over 2.
the opposite, -3 halves. Just change the sign of this. Just change the sign of this.
Wait, how do you know which one is going to be the x value? Since there's 2 of them.
I'm gonna have 2 x values.
So you have to write both of them.
You have to write both of them. It's a second degree equation. It's a parabola, crosses the x-axis 0 once or twice. Okay, now let's look at this factor. I can simplify it, can't I? 2 becomes 1 and 10 becomes 5. So what's this factor?
Is it -5?
X minus 5. Yes. What is the x-intercept?
5 over 2.
Positive 5 over 1. Got it? That's why I like this method. It not only gives you the factors, it gives you the solutions. Yes.
So is your answer what the x-intercept is, or is it the above that?
Right now, you're here,
Okay.
but you need to have the answers. You need to be able to solve them.
Wait, so which one would you circle?
This lesson is factoring.
Okay.
Few lessons, you're solving.
Okay.
Got it?
Yes.
If it's set equal to 0, you're solving. Right now, it's just teaching you to factor. Got it? All right. Let's do another one. Are you getting this? All right, example 3. Now, actually, we have an equal sign, so we have to be solving. All right, so what must I do first?
Move the -6x squared to the other side.
Correct. It becomes positive 6x squared minus 5x minus 6 equals 0. All right, I'm looking for factors of what?
A and C, so 6 times -6.
Which is
36, -36.
factors of -36, such when I add them together, the result is
-5, so -9 4.
-5. Got it? Everybody have this so far? So like Caroline said, the factors have to be -9, +4. Everybody hanging with me? Yes.
Oh, never mind. I see it.
Everybody's hanging. All right, now I write that lead coefficient with an x, and I simplify the numbers. In 6 and 9, 3 goes into both of them. So that's 2, that's 3. What's that factor?
2x minus 3.
What's the answer?
It's 3 over 2.
3 halves. Just change the sign. Everybody following this? Got it? 6 and 4, 2 goes into both of them. So what, that's 3 and that's 2. Audrey, what's that factor?
3x minus 2.
It's going to be plus, yes. And what is the intercept, the x-intercept?
2 over 3.
Change the sign.
Oh, -2 over 3.
Yes. Got it? Everybody got it? You like these? I like these too. Actually.
Like 6 of the same problem.
It feels like 6 of the same problem, huh?
I think it is.